Hi, everyone. My name is, my name's not here. My name is Wei Lu. Have been a programmer since I was 10 years old, so it's a long time ago. And as an old dog, it's hard for me to learn a new trick. So what I'm trying to find is the ultimate weapon to use AI to code for me, code for us developers. What I'm doing is the consulting work for AI, so for software development. And I'm living in Finland most of the time. It's only 2 hours flight from here, actually. And yes, there's a lot of reindeers and a lot of Santa Claus. Yeah, believe me, there's a lot of Santa Claus in Finland. And of course, we also have the urban life in Finland too. And I do travel a lot to China for the CSDN projects and CSDN customers. CSDN is the largest Chinese developer service company. You can say it's the Stack Overflow plus GitHub for Chinese developers. So we serve a lot of Chinese developers. We have a very high coverage of the Chinese developers. So in the world, if you would like to reach the Chinese programmers or Chinese developers, we can help. And we go to a little bit of history of the code generation. Indeed, it's a long history, but in the old time, it has another name called like the program synthesis. And now the fashion name is code generation, but to me, it's almost the same thing. So in the old time, in the age of a high-level programming language, at that time we say the Fortran compilers are recognized as kind of automatic code generation system to transfer the high-level programming language statements into machine codes. And then we have a logical programming language, such as Prolog, and we can describe the requirement as logical expressions for computers to perform automatic reasoning to derive solutions. And in the beginning of the new millennium, UML, the model-driven development, we also have the effort to try to generate code directly from the model. And in 2015, this is the orange part, is that we go into a new area of using neural network to generate code. So this is one of the first paper to research on the code generation with neural network. At that time is the recurrent neural network. It's a very small neural network comparing to LLM today. And in 2020, there's one of the earliest research of using pre-trained, we call it pre-trained language model for code understanding and generation is Cook-LLM and CodeBird. And the Cook-LLM is about, if I remember correctly, it's about 104 million parameters. And the BERT is about 4 to 1.2 billion parameters. And at that time, we have a lot of research on trying different structure of neural network and different way of training the neural network to optimize for the code. But then OpenAI got a new way to, with a paper on Codex. That's the first pre-trained code generation model of 10 billion scale of the language models. So after that, we go another way to use more larger and larger model to do this kind of work. So for me, the entire history of the process of humans striving to create machine instructions through increasingly abstraction levels. We believe that following the high-level program language and the model-driven approaches, the key to further enhance the abstraction level and the efficiency lies in the common sense and the world knowledge which is building in the large language model, because they can do some kind of reasoning we can imagine before with this kind of rule and template-based solutions. And it can also to do, we call it flipped instructions. That means the machine, the model, can reversely ask questions to the programmers to clarify the details of the requirement. And that's also something we can imagine with the classical rules and based solutions. And we look a bit about the needs and expectations by today's programmers. The most time-consuming activity is, of course, writing code. And there's also some survey on how today's programmers using the existing AI assistants like GitHub Copilot. For the questions, how frequently do you use the following feature of the existing AI assistant for coding, like GitHub Copilot and ChatGPT? The second most often is generating code, writing code. And if we ask how likely is that you would delegate the activity to AI assistants, writing code is at the bottom. It's very interesting data. Maybe you don't want the machine to replace your job on writing code, but the fact that maybe the machine do code better than you now. And another statistic shows that the acceptance rate of Copilot generations varies among people with different level of experience. This data shows that less experienced developers have a higher accept rate. What accept rate means that if the Copilot or ChatGPT generate a piece of code and you, as a human, accept it as your solution or not. So the less experienced developer have a higher acceptance rate. So whether this is because the task of less experienced developers are easier for machine to complete, or because they are the less experienced developers just use AI tools better than the experienced one, or just because the most experienced developers are more likely to identify the problem of the AI generation. It remains to be further studied. It's still questionable now. But the clear point is that the people with different levels of experience have different expectations and use patterns and the level of satisfaction with today's AI. And this is what the AI community can offer to our software developers now. The model size increases from tens of billions on the BERT model to hundreds of billions for GPT-4 and Gemini. And the response speed will gradually slow down with these solutions. And the picture roughly shows what kind of task requires what scales of a model to do the work. For example, the line completion, the code line completion, we can do it with very small models. But for some, like the completion, which has to be based on a larger repository of the code, we need to use much larger model to accomplish this task. And that also means the response speeds will be much slower with larger models. And regarding the code completion, for one line or the body of a function, the acceptance rate, what we can achieve with the current solutions is about that. The GitHub Copilot, it can make the acceptance rate in about 28 to 35. And now it's used by, according to their data in the website, it's used by 1 million developers globally already. And in China, Baidu has a similar solution called CodeMate. It gets a higher acceptance rate, performance a little bit better than GitHub Copilot. It has been used by 80% of the internal developers in Baidu already, and about 10,000 organizations in China already use this kind of solutions. Alibaba and some of the Chinese developers, Chinese software developers, they have already tried this kind of solution and get quite impressive performance already. And this shows the core elements of the implementation of this typical code task with AI assistance. Similar to previous machine learning technologies, data, this part, is still the fundamental of everything, even magic. The model's coding ability primarily comes from the, open source data on GitHub and some proprietary repository in the corporation and the documents on the code. But today, this data source largely exhausted, so the synthetic data will play an increasingly important role, and we will cover a little bit later on the synthetic data. And this data is a little bit different than the data of code is a little bit different than the nature language data, so it needs some special handling, like cleaning the copyright issue or the flaw of the code or the duplication of the code. And the format, for example, for source code, before we inject it into the training of the LLM, we need to insert, for example, like the file name and the language tag and something like this. We need to format the code before it's used for fine-tuning and training of the language models. And for easier tasks, like the code completion or unit test generation, the LLM can handle this pretty well already, but we need to provide the LLM with some appropriate context information for the generation. But for some questions, some complex questions, for example, the questions not regarding general coding questions, but to a specific code base, and we need use some kind, we call the retrieval augmented generation techniques to make the LLM work better on a specific code base or a specific domain of the knowledge. For more complex tasks, the LLM's own ability are utilized to break down the complex task into subtasks to make it easier for LLM to handle. And multiple calls to the LLM for a single question has to be organized, and the information in the conversation should be recorded, and the external information and more tools are integrated for this task. This ensures that each call to the LLM can use the most appropriate information to generate the final answer, the final solutions, step by step. And we will cover some details later. This is an overall picture. Yes, as I mentioned, the code data and natural language data is a little bit different. The natural language model in ChatGPT or generative AI is to predict the next token as one of a sequence of tokens. But as all developers know, the source code is not only a sequence of character or sequence of tokens, but it's also a structural content. So a piece of code segment is depending on the prefix and suffix of this file and other files or the dependency of external models. So it is not only dependent on the code in front of before this line, before this function body. So in addition to the pre-training of language models, we need to add another step to do we call the fill in the middle task in the pre-training of a language model to make it work better on code. The way is that we will just extract part of the code. It can be a block of the code or the body of the code, which is based on the abstract syntactic tree. And the information to train for the model to predict this part, we may also provide other context information, like the core graph of this program or the file dependence, which means we need a longer context for the model to predict the part, the span to be trained to generate or to be trained to predict. And in the inference time, the RAG will help also to handle this without retraining the model. We will cover this later. But the point is that usually we need to do a further pre-training on a language model to make it work better on code. And the synthetic, as I said, besides the open source code or private code, we don't have enough time to train the language model now. So there's a lot of method to synthesis data for the code training, for the language model training. There's a lot of, we don't have much time to discuss all of this method. What I'm going to mention that, for example, the tackle, this is a training set. The basic idea of synthesis data for code training is that we take some typical code, for some piece of good code, and we use LLM to explain this code, which means that this explanation of this code can be a good instruction of the code generation task. Like this, for example, we find a very good hello world piece of C++ code, and we use LLM to generate an instruction to generate this piece of code, like the instructions that just give me a piece of hello world code in Rust or in C++, and then we can use this pair of instruction and code to train the models. That's the basic ideas. And the last one is very interesting, that which is released just a few weeks ago. It's very special is that most of these solutions are using GPT-4, a much stronger code to generate data, to train a weaker code, to make the weaker model, to make the weaker model more stronger. But the start code to instruction research, they found that they can use the same model, which is trained only on a language model. The start code 15B, it's relatively weak model, but it can generate data to train itself, to improve itself. That's very interesting research, and you can read the paper, which means now we have, we call it the intelligence flywheel. We all know about the data flywheel concept, which means we have a model, we have AI, and the AI help people to do some work, and that the work is a good data to train the AI to make this AI better. That's the concept of data flywheel. Now we have an intelligence flywheel, which means we have a model, a weaker model, and he is able to generate the data to train itself, to make himself stronger. That's very interesting phenomenon. And so the key point of synthetic data, we believe that is the seed case, some good quality case as a seed to make the LLM to generate, to mimic the good quality use case and to generate more new use cases. And the human know-how and the standard operation procedure are mostly the important factors in synthetic data. And we also need more engineering artifacts to train the model, because for now we have only the final results of code in GitHub, and we don't have the original requirement file, we don't have the intermediate engineering artifacts to train the model, to tell the model how this final code is developed step by step. So the intermediate engineering artifacts is also important to train a better model, a better coding model. Another issue of the data engineering is that we need better evaluations now. The most dominant evaluation is released by OpenAI, which is called the Human Eval. The task is algorithm or competition questions, and it aims to generate, it tests the ability of LLM model to generate an independent function or method without dependency. Obviously, this kind of task is far from our real-world software development needs. And because it's so popular, so it's easily contained during the training. And recently, there's another evaluation data set called SW Bench, which is try to make the LLM to resolve real-world GitHub issues. That's a much better evaluation data set, but for now it's too difficult. Even GPT-4 gets very low score on low resource rate in this evaluation yet. So what we need now is we need better evaluation data set, which represents tasks close to real-world development scenarios. And we are also very interested in the evaluation data sets specialized in specific programming language like Rust, or some like standard library of this kind of library and package, which is not available yet. what we have is just a general test of the most popular language. For Rust or some less popular languages, we don't have the data set to evaluate it yet. And we believe that today, most of the evaluation is comparing to the high standard of people. But we believe that we also need a different kind of evaluations comparing to different kind of human experience levels. Indeed, ChatGPT also knows that, for example, if you ask ChatGPT to write a program like a junior developer, he do this like that. And if you ask it to play as a senior developer, he writes a different program like this. Yeah, the staff engineer and the principal staff engineer, a principal staff engineer in the large corporation, the model knows the difference, but our evaluation data set doesn't have this opportunity to evaluate the model yet. Okay, we don't have much time, so we will go a little bit quicker. So that's the easiest task like code completion, what we need to concern and what we need to do. We need not only to generate high quality of result or high quality of generation, but also to respond quick enough. If the latency time is larger than 200 milliseconds, the program just ignored it. So for this kind of task, we use these solutions to make it not only better, but also quicker. RAG is the retrieval augmented generation. It helps to mitigate the problem of LLM's problem of coding. And for example, the hallucination in coding tasks, it will generate non-existing function or variables. And the knowledge cutoff problem of LLM in the coding domain is that it will use outdated version of library and APIs. And the customization problem is that the LLM cannot use a specific code base or document. So the retrieval of the RAG is used to handle these problems. And the basic concept is that we can use some relevant context information to put inside the prompts, the instructions to the model to make it the generation better. We just show some example. For example, when we generate like this, the green part, if we don't provide the relevant information in another file, it will generate maybe any kind of strings is correct to the LLM. But indeed, in this case, we need to find the relevant information for the LLM to generate the content we really need. And the dependence is not, sometimes it's not only in another file, it's also in the dependence from the import or inclusion. And based on the import or inclusion, we find another file, maybe this file is in totally different repository, but it's also, we need to also find this kind of information for LLM to generate a correct answer. Code embedding, this is a new way to find the information. We can, let's just go to the conclusion of a best practice that we use a vector-based retrieval, which means we can find the information which is not look exactly like the query, the requirement of the the query, but semantically, they are correlated. And we also use the keyword-based search as the classical way to find the related information. And then we combine this result we use a more powerful, we can say, a more powerful model to re-rank it. For example, we need to find 10 relevant piece of code or document to solve a question. Then we use the embedding model to find hundreds of semantic similar records, and use keyword-based search to find another 100 similar piece of information, similar document. And with these 200 records, we use another LLM to select the most appropriate 10 records for us to help LLM to generate the final answers. This is a little bit different than the classical search and retrieval solutions. So, agent is like what I've just said in the overview picture. In addition to the element of agents mentioned earlier, the current practice often involves multiple roles to create a multiple agent system. For example, the agent code implemented programmer and tester design agent powered by LLM, and a tester executor agent powered by Python runtime. The concept is very easy, that we ask one LLM to play as a code generator, and another LLM to generate test case for us. And the third, of course, we don't need to use LLM. We use a Python executor to execute the generated test case to verify if the first agent, the code-generated LLM's result is correct or not. That's the basic idea of the so-called multi-agent system. And actually, most of the secrets of this so-called agent solution lies on the prompt of the system. That's what we ask the instruction to ask the LLM to do. So for most of the agent systems, it's not that the magic is just if we can find the prompt definition in the source code or in the configuration file, it's very easy for everybody to understand because the prompt is in natural language, actually. And GPT Pilots is another multi-agent system which defines more roles, like specific writer agent, architect agent, tech lead agent, to simulate a software company to try to solve a more complex problem of a software company, like maybe for some easier task, software development task, we can use multiple LLMs to directly generate like a game, a website, a web page game from some very basic requirement. And you may hear the media report of Devin, like the first AI software development. The SW agent is an open source version of this kind of AI software engineering. It's not fundamentally different from Agent Coder or GPT Pilot. It has tools. It just has more tools and workflows suitable for GitHub issue handling. So in summary, for the agent techniques, tools, and standard operation procedures for the LLM to learn to mimic the behavior of people, as experienced engineer or a software company. That's the key is the roles and tools it can use and the standard operating procedure by real human and human organizations. Yeah. And at last, we have some idea for the open source community. As we discussed a lot today, data, not necessarily big data now, is the new generation of source code, because the new software with neural network is driven by data. Data is the new source code like today. And what we mean data is seed case, good case, and standard operations, and engineering artifacts as we discovered. And all these data are the new valuable things for the neural network era of software. And for the corporate to open source the proprietary code or document, we also need to develop some de-identification or anonymization solutions, or to make them safe to open their data, because their data, their source code and document, there must be some very sensitive information, so they cannot share the code to the open source community to train the models. But what if we have this new technology to filter the sensitive information in source code or document, so they can share the data to the community? Why they share the data to community? Because if they share the data to community, the open source language model can be trained on their data. So the open source model will behave better. The performance will be better on their task. So that's the idea. So some mathematical tools like differential privacy can be used to develop this kind of technology. And also, LLM as new tools, as we discussed today, may also be a new tool to develop this, to provide this kind of de-identification or anonymized solution for the corporate to open source more of their internal data. Yeah, and I would like to share, this is a conversation with one of my Chinese friends who's one of the AI practitioners. The conversation is that we discuss about GPT-3, called Llama 3 or some new models. And he said the evaluation metrics are one aspect, but the word of mouth is another aspect, and the later will be more increasingly important to say a model is good or not. And my comment is that word of mouth is essentially a small amount of test data used by real users of the model. And such data is highly valuable and would become an important role of the open source movement, like the open source code today. And he said, yes, I personally have very few fictional use cases, but such use cases are the most effective way to test the model's capabilities. Models that cannot pass my personal use case are not worth spending more time on it. He does not see the human error score or other scores. He doesn't care too much about, but he used his very personal test case to say this is good or not for his own purpose. So what my opinion is that this kind of personal use case is very valuable for the development of LLM technology. And this kind of, to open source this kind of knowledge will be like what we open source code today. Yep, this is my talk. Yeah, we also run after time. If you have any questions, you can reach me.